So where does margin of error come from? First of all, what is margin of error and where does it come from? So remember, margin of error, we drew it right up here, is the distance from the edge of the interval to the center. Okay, and in this particular one, we were told that it was 7.7%. Down here, a little bit later, we had 8.3% margin of error for this one, or 6.9% margin of error for this one. When we were on the CNN polling sites, you could see different margin of errors. Like down here for this one, that's 4%. Poll of polls is not appropriate, so they don't have those. 3% on this one, 4% on this one, and so on. Okay, so how do they come up with that number? Where does it come from? Well, the answer is it comes from the formula, right? So we have this formula for it. And if you noticed, it's in the interval right here. So you take your p hat, that's your point estimate, and you add on and subtract away your margin of error. And then it's really a z-score times the sampling, the standard deviation of the sampling distribution of sample proportions. All right? Okay, now just keep in mind that you don't always have to use this formula. So if I give you the interval ahead of time, you don't need the formula because you can just take the outer edge minus that middle, right? Like we did way back here. So if I had told you this was 25% and this is 32.7, you could have found that it was 7.7 just by doing a simple subtraction problem, okay? But if you don't have the interval pre-given to you, then you got to find it yourself. Now, if you're going to use this formula, you're going to need to know how to find the z alpha over 2. So we got to do that. So, and by the way, that comment I just made about how sometimes you use the formula and sometimes you just take a subtraction, that's what this little note is right here. All right, now in section 7.2, we learned about z-scores and how to find them. Namely, we have to use inverse norm. Norm, it's norm inverse for norm.inv for Excel. So you can use the norm.in function, and then we kind of play around with that. I'll actually fiddle with this just a little bit. Or we can use StatCrunch to find it. Now, keep in mind that when you have a z-score like this, it means that the area in the right tail is equal to alpha over 2. Okay? All right. So I think I'm going to use Excel for the first time. So let's open up Excel. And actually, I'm going to use StatCrunch as well, just for the sake of it, just to practice. All right. Oops, I need to get rid of these symbols, though. That's not helping us. Okay. All right. So this is our level of confidence, which we'll call alpha. There is a way to insert the symbol, by the way, if you want. It's under Insert, Symbol menu, and you roam around and look for it. There it is. It's a Greek letter. Close. And then the area in each tail is alpha divided by 2. So if you want the symbol, knock yourself out. I do not like how this is the wrong size, though. That's not good. There we go. All right, so our critical value is z alpha over 2. And again, you don't have to use the symbol. You can just write alpha, A-L-P-H-A. But whatever. It's in the Greek symbols. Alpha over 2. It is not liking me. There we go. Okay, so we want to be able to find all of these. Now, keep in mind that if you have a 90% confidence, that means that you have how much in each tail, right? So if you're, oh God, that's not level of confidence. There we go. Okay, so if your level of confidence is 90%, then alpha is equal to 10%, right? And so alpha over 2 would be equal to 10% divided by 2, which is 0.05. All right, similarly for this guy right here. So remember, the alpha is the complement. I mean, if you want, you could even little insert in here. There we go. Alpha is equal to 1 minus the confidence level, okay? So they're complements of each other, if you will. I'm having issues with my border here. Okay, cool. Okay, so that means that this was equal to 1 minus 90%, right, which is 10%. And then you take that and you divide it in 2. Right? And we tend to do decimals for both of these. They tend not to be percentages. It's not necessary strictly, but Let's just make them decimals. Cool. And then we can do it again. We can say, okay, I want 1 minus this other value, which would be 5% in both tails. And then you cut it in half, and that's how much is in each tail individually. And we totally need more decimal places than that. So let me go to Format Cells. Let me pick General. There we go. I shouldn't have picked Number. Number restricts how many decimal places you have, and I don't want to restrict it. Okay, so now I need the critical value. Now we can do this a couple ways. I'm going to use Excel to do it right this second. Okay, so it's equal to norm.inverse. Okay, so you want the left tail probability. You know what, let me take a moment. I'm going to go do this in StatCrunch first because I want StatCrunch to give me a picture. That way I can use that picture to help explain to you guys. So let me open StatCrunch. Go to Stat, go to Calculators, go to Normal. Okay, so we're on the standard normal curve, so 0 and 1's fine. And I want the area in the right tail to be 0.05. Okay, so because the middle's 90%, right? So you've got 5% on this tail, 5% on the other tail, and there's a middle in there that's 90%. Actually, let me go draw a really good graph. Hold on. Here we go. I know it's like magic. Here it is. Okay, so you want 5% on this tail, 5% on this tail, and then in the middle is 90%. Okay? So we need to be able to find this value down here and this value down here. Now you can see that Minitab's telling us it's 1.645, but you of course will not have Minitab to do this for you. So you've got to be able to find it yourself for your Minitabs, and also just for your own sanity, because you're going to have to do this over and over. Now I'm going to draw a picture. I'm going to insert that picture in here, even though when you're taking your notes, you're just going to draw it by hand on your note sheet. But we just want to keep this in mind for our own, image in our head of what's going on. So what we're going to do is we're going to make Excel and or StatCrunch find these numbers for us, this 1.645 business. Okay, so let me go back to StatCrunch over here. Oops, it's under the Java thing. And you can see that I typed 0.05 because that's how much is in that right tail. And it's telling me it's 1.645. You can see it right there. I'm going to take a snapshot of it. This is 9.1. What was this? Example 3. Okay. Example 3. It was really the first one of those, but that's okay. Okay, so I've got that. And I will go paste it into my lovely Excel here. Oh, rats, not that. I still have to go to my results. There it is. Copy. There, now I'll get it. Cool. So you can see StatCrunch is telling us it's 1.645. Right there, 1.645. Now, how will we get Excel to find it for us? Equals norm.inverse. Now remember, norm inverse, and again, if you have old school Excel, it's just norm inverse with no dot in it. But norm inverse takes the left tail probability, not the right tail. So you have to tell it this whole white region over here. Well, if this little red tail over here is 0.05, which is what we just found right up here, that cell, right? So we need the reverse of that. You need 0.95. If you will, you really want 1 minus that value you just found. So 0.05 is the red bit. So everything else is 1 minus 0.05, comma, your mean is 0, comma, standard deviation 1, close parentheses, enter. And then because I did this craftily, I can just drag it down, and it found the others as well. And it's not a bad idea to find them with StatCrunch as well. So let me go back to my StatCrunch. Stat, calculators, normal. I want this to be 0.025, compute. Oops, oh no. What's the problem? It's not really wrong that way, but I wanted the right tail. So I'm going to go 0.025 on the right tail. Make sure you change this little arrow to the right one. There we go. Take a snapshot. label it, etc. All right, I'm going to pause. I'll be right back. I'm going to do this again, and I'm going to copy and paste them all into Excel. There we go. Now I got them in there. And you can see they're matching up. See the StatCrunch number right here is 1.9599. That's matching what we found with Excel. And over here, 2.576. That's matching what we found. So use Excel or use StatCrunch, whichever. There's actually another way as well, which I will show you later, which is even easier in many respects. Okay, so now we've got these numbers. I'm actually going to take these back and copy and paste them back in. For me, you can just write them by hand. There they are. Okay. So you don't really have to memorize these. These are actually, and I'll show you later, but these are actually on the table sheets that you get in your exams. So none of this has to get memorized. You just have to know how to find them, right? So, and of course, with online tests and quizzes and stuff, you have to be able to do it with either your calculator, with Excel, with StatCrunch, with something like that. Okay, but there are some that are really obvious. This one in particular, by the way, the 1.96. That one we're going to use a lot. We're going to use all three of these. These three are the ones that we use the most often. That's why I put them in the notes. But this one in the middle especially, we use that one a lot. Because 95% is the standard for CNN and all those places. Gallup, Fox News, NPR, they all use 95%. They don't tell it to you right here. You'd have to click on the information stuff and they'd tell you about it. Okay, but 95% is old school. That's what they were doing back in the day when they didn't have calculators anymore, and they've just kind of stuck with it. So that one tends to get used the most often. All right, now from here we're going to at least start the next problem. We won't finish it, but we'll get started. Which is in class, suppose we wanted to know the true proportion of red beads in our box. Suppose you reached in with a scoop and you got 30 red beads and 90 white beads, just like we had said before. In order to even think about making an interval for this, you have to check that n times p times 1 minus p is greater than 10, and that little n was smaller than 0.05 capital N. All right, so let's verify that this is holding true. So for us, our scoop was only 120 beads. And I'm just going to tell you right now, that is not nearly enough. It says little bitty scoop. This box has a lot of beads in it. So a little bitty scoop is not more than 5% of this thing. So I know that's a little hand wavy like a magician, but that's just what we do a lot of the times with that particular one, because that particular requirement so often is like, well, of course I was less than 5%. Geez, I only took a small little Dixie cup. What were you expecting? Now we also want to prove that n times p times 1 minus p is greater than 10. That way we'll have normality. Now n is 120, p hat was 0.25 for us, and then 1 minus p hat is 1 minus 0.25, and you multiply those with your calculator or whatever, you're going to get 22.5, which is bigger than 10. So that means that our data was normal. Yay, team. And from here, we go to making the interval. But we don't have time to do it in this video, so I'm going to stop right here, and that's where we're going to pick up next time. We're going to make an interval with formula substitution, and then we'll use Excel and StatCrunch to finish the job for us. See you then.